Hello, good morning. Welcome to my shop. Today is August 23rd. Took a couple days off there. A little trip with my wife. Now I'm back here in my shop. And it's, wouldn't you know it, it's another sunny, beautiful day here. So, okay, what are we going to do in fairly quick order? Quick recap. Where am I at here? Well, partway through changing out capacitors. Done the ones down here and took a look at the filter capacitors. They seem to be okay for now. The radio does produce a hum, but I think it's coming from another kind of problem. I've discovered this big capacitor here is related to the is it the output tube grid? A decoupler, I believe, if I remember right. Okay, so the rest of the business is up in here, and you know, from where I am standing up here, by the way, looking at this. This is what it looks like to me. Can't see anything up here. So I don't want to work standing on my head. I'm going to flip this radio over. Luckily it's got this very strong front plate, so even though I'm going to flip it over and have the transformer up in the air, which makes the chassis unstable, a little bit unstable, I think I'm going to get away with it. I'll be able to see much better what we got here. Okay, all ready. Now, what did I just feel? Did I just feel this transformer shift? This brings us back to the loose plate here. Now you can really see the grommets in here. Used to be thicker and they've shrunk, and this whole thing is just floppy oppy. Yeah, okay, that's the ground band, or bond if you like, between this metal plate and the chassis. Thought it was broken there for a moment, but it's not. Okay, now, is that all I felt move? I think that's what I felt. I thought for a minute I felt the whole transformer move, but no. It's just this thing kind of flopping around. Okay, very good. There we are. There's the little critters right there. 1, 2, 3. This is a different type again. This was the same type as the kind that was on the what? I have to turn the radio upside down. I don't recognize anything. Okay, we won't worry about it. So I got this type, these two are the same sort of very typical wax capacitors that depend on the wax coating to make them, to prevent water from entering them, or moisture from entering them. This one has a plastic shell, but apparently, I haven't broken many of these open. Inside here is basically one of these. So I understand. Well, I only see 2 there. 3. I only see 2, 3. Let's do them, and then we're going to find out what this radio can do. I'm gambling that this is why it's a little weak. One of these guys. These 2 are going to ground. This one seems to be associated with this battery. That should be easy to find on the schematic. And this one's going right to a particular pin on the I think mixer tube. I think that's the IF amplifier tube there. Let's find out what this one is, because it's going to be easy. It's on this battery arrangement. Okay, to the schematic. Okay, there are 2 cells, 2 battery cells in the radio. Here's one here, and there's one here. The one that I'm interested in is this one, and there's the capacitor right there. So if we look at what's going on here, this is the output of the first IF transformer. And this capacitor will make basically a signal ground appear here. So the entire signal developed in this coil is between the top and the bottom. Well, it's also, you can look at it another way. If you follow this line, this little battery is also supplying bias to this tube. And there's a 2 million ohm resistor here and a capacitor here. So you think if there's any signal, it's going to fight to get through the 2 million while it's easy to drop through the 0.1. I think that's kind of the idea. So that'll decouple or eliminate any signals traveling on this wire right here. Just be DC coming up here, especially here. Of course, you don't want a signal from the grid of this tube getting back to this one. If this capacitor were removed or didn't have any capacity, couldn't do its job, I think this radio would be howling away. So chances are this is, again, doing its job. This is the paper one. It looks to be in good shape. I'm just looking at it now. Now, the other capacitor, as we'll keep looking at the schematic here. So another of the three capacitors is tied to a wire that goes out to the tone control. Right, here's the tone control. Wait a minute. This is the tone control here. This is the volume control. I turned the radio upside down, so of course I'm totally confused now about what is what. Yeah, this is the volume control. This is the volume control. They just sort of pictured it on this. Just a little odd how they've shown it. I guess what they wanted to do was show that the wires coming in, going out, and going to ground are all under a shield. I think that's what they're trying to show. And there's a fat cable running through the radio with those wires in it. It doesn't look like a shield. It just looks like a cable with 3 wires. Not that it really matters. It just proves what I'm looking at. And then there's a capacitor tied to one of the 3 wires. There it is there. 0.05 signal going through it. Didn't I change this one? I don't think so. So that's probably what that other capacitor is. Now we got one more to look at here, which is tied to a tube. Let me just stop for a second. We'll just flip back to the other. Flip back to this view. So this is the guy we looked at first. That's a decoupler. This one's passing the audio through it. So obviously, if this one were weak, it would weaken the audio. The audio's sort of okay in this volume level. And then this one is the one we need to figure out yet, and it's on this tube. This tube being the 6A7. Okay, let's go back. And which pin? Which pin is it? It's pin number. Let me feel for the. Okay, so that's 1, 2, 3. Would appear to be on 4. Pin 4 of the 6A7. Pin 4. Okay, 6A7. Pin 4. Well, if you want to believe it, that's 4 written right there. So the screens, this is the screen coming out. Is it on this one? No. Well, maybe that's it. I've done this one. So let me just look a little more. Pin 4. There's another wire on pin 4. So we come down, pin 4 again. I think we'll get another wire, yeah. So there's a wire going up this way. Now there's a resistor. This also goes to pin 4, screen in here. It's making a little bit of sense. A 60,000 ohm resistor here. So there should be a 60,000 ohm resistor tied to this capacitor if I've got the right one. Okay, let's go back and look at the radio. So, okay, so this wire comes way over to here. Oh boy. As soon as these things start getting a little long, I get worried about trying to trace them. I don't see any resistor. Oh! Sounds like a chiropractor just worked on this radio. So that was me pushing a wire that was pushed up against an unused tube terminal like this. Pushed up pretty hard. And so wow, is there a short there? I doubt it, but I don't know. So I pushed the wire away and you heard it. As the insulation just cracked away. Okay, no problem. Hasn't caused a problem. Maybe I got rid of a short. Not very likely. Okay, well, I think we just go ahead and change these guys. If this is a 0.05 and I can't, this is supposed to be a 0.005, this should be a 0.1. It's supposed to be a 0.05. Hey, what's the schematic say about the size of this one? 0.05, eh? Let me look. Okay, so the one we think that is right here. No, I've lost track of what I was doing. So there's the 0.005, there's the 0.1, and the last one, clearly I haven't drank enough coffee yet this morning. Pin 4. Well, this is a 0.1, and what's in the radio is a 0.05. 0.05. So look at a 0.05, C41. Feel like I've been here before. Only one 0.05. And C41. This is C35. 0.05. I remember this 0.05. So that's been changed. There it is right there. I've changed that. So it's a wrong size capacitor here. Instead of a 0.1, you put a 0.05, which is kind of going in the wrong direction. Could be it's, it's such a small factor in the operation of the radio, it didn't really matter, but a little surprised. Okay, so that should really be a 0.1. I just have this terrible deja vu feeling here. Okay, let's go ahead. Let's do the thing. I'm going to change those capacitors, and then we'll see what happens. Okay, first capacitor's changed. There's the new guy. This is the one that conveys all the audio through the volume control. 0.005. Let's give them a test. If it tests good, fairly good, as many of the capacitors have in this radio, then I won't bother testing the radio. I'll just assume not much has changed. Just replaced an okay capacitor with a better one. Let's see what happens. We're at 50 volts. Watching the eye. Very hard to see. Oh. Okay, here we go. What do you do, eye? Right open. Okay, 150 volts, right open. So that's enough of a test. So nothing seriously wrong again with this capacitor. So very surprising. A radio from 1937. Unless these have all been changed and I'm just not picking up on the fact that this guy's been in the shop a number of times and had a number of people replace a number of those capacitors, which might explain why these are different types. All the soldering looks original though, at least for these. Okay, next one. So we're not going to test the radio because I don't think I made much difference there at all. We'll go after this one next. This is the one that quiets. I can't remember. Okay, it's just more proof that I need to drink more coffee early on. So this one was the one that is it's not this one, so it's this one here. So that's the guy. I got myself to, oh yeah. Jim, you're confused here, aren't you? This is a 0.1, and this is a 0.1. 1, 2, 3 0.1s in here. Okay, let's see what it actually is now. 0.1, eh? Point 1. 200 volts. Yeah, it's on the grid, isn't it? Wasn't that on the grid circuit? 0.1. Okay. I'll install a 0.1 there. Okay, that one's done. Oh, I guess if I were gambling, considering what's been happening with this radio, I'd have to gamble that this capacitor is good. Looks as good as any coming out of a radio. Is this really from 1937? Does it say something on it? Made in USA. Patent number 1,900,000. It's got the other no. There's no date. I've never found a date on one. It would have been great if they dated them. Okay, 50 volts. Watch the eye. She's slowly coming open. Just about all the way. Okay, 150. It's trying to, it's not going to open at all. So this one's not so good. But again, as capacitors go coming out of these old radios, these are all testing pretty darn good, really. And could they be responsible for poor performance? Boy, I don't know. Okay, let's go with this last one. Now I got to decide whether I want this to be I should put in a 0.1 here, really. I guess. Okay, and I'm going to test it right away here. Let me attach my memory device here. There. Okay, where'd it go? Here he is. There's no manufacturer name on it. Oh, there is in there. Canada. Sangamo, Canada. You just gotta imagine. That if a factory were building this radio, when this radio was being built, that the parts were all the same. Okay, maybe that is the story here. This radio's been worked on a lot, and that's why, like, this capacitor looks fantastic. Let's see what happens here. Okay, 50 volts. Block the light a bit. Here we go. Okay, it opened right up on 50. 150. Can't do it. You can't do, a tiny little hair line crack. Okay, so there you are. It looks fantastic, not so good. We can't test the value of these because they're too leaky to get a valid value out of any kind of testing. Okay, we'll put in the new one, then we're going to test the radio and see if I've buggered it up or not. Okay, very good. We've got 3 capacitors in. Okay, it's good. We'll stand this guy down, set him proper. Let's go like this. I noticed where the antenna wires go through the chassis down here. It looks like they could have been roughed up enough that the insulation has failed and there's a short right there. But I don't know. It just looks that way. Okay, I'm going to plug in the speaker here. There it goes. Okay, here we go. Get the angles right on it. Yeah, these wires are really frayed. The cloth covering is frayed really badly in here, and I gotta wonder about the insulation underneath. It's very stiff in here. Yeah, wow, it's very stiff. Yeah, there's a very high likelihood these wires are shorted right here where they go into But maybe not. You never know until you find out. You never know until you know. Okay. Just neaten things up a little bit here. Power's off. Plug it in. Okay, switch is on. And we're on. That knob is loose again. Somebody come in here at night and loosen it up? Must be my cats. How's that ever going to stay tight? Okay, I'm back to using a wrench. Crying out loud. That would be shortwave. This would be broadcast. Am I all the way? Can't feel anything on that big tool. Okay. I think we're okay. Starting on broadcast. Need an antenna. Here's one. Not a very good one, for doing broadcast stuff, but no antennas really are these days. I was writing a long email yesterday to a person who asked me about antennas for shortwave radio, and they don't know anything. And I had to explain, we live in a world full of radio noise now, so if you're in your house, good luck with an AM radio. And you really need an antenna outside. And even then you can't escape all the noise in that. So people have a memory of listening to AM radio years and years and years ago, and they want to bring up an old radio like this and get that AM radio experience again, but it's tough. It really is to do it. A loop antenna is a real helpful thing for broadcast. Okay, enough talk. I think we're all set. Just taking a last look. I think we're good to go. Okay, here we go. You can see the little dim bulb pop on briefly. Perfect. And the volume is there. The volume is there. There's still a terrible hum in this radio. Listen to that. That's a bench shaker. I have to take a look at the power supply again because okay, broadcast. Oh, it's just horrible tuning here. Didn't I say I was going to work on that next? Come on, anybody. Something not right here. Okay, that's a good sign. That noise is interference I hear in my shop all the time. So it's receiving it. As far as the radio knows, it's music. So the scratchiness here is quite a concern. She's receiving. Okay, now let's change this. I don't like that hum at all, but we'll now go to shortwave. Oh, it's really terrible using a big wrench on something like that. Okay, we're on shortwave band. Volume way up. Not at the top, but close. There's a station around 9 megahertz, right around in here. Strong one. Sometimes. Maybe not today. Okay, listen to her voice really carefully. Can you tell it's modulated by the same hum? I'm pretty sure the same hum we're hearing out of the speaker is modulating her voice. Where's it going? She sounds like she's underwater. Well, that's good. That's enough. That's all we need right now. I was doing that whole thing on low voltage supply. Well, I'd kind of hoped the hum would be gone by now. I guess I'll have to revert to the power supply and look at it more closely. Just what exactly is causing the hum. My previous check was somewhat precursory look at the hum percentage in the B+, and it seemed very low to me. But it sure doesn't sound low listening to this radio. And where else would a hum like that come from? Not too many other places. So two things here: deal with the hum, and fix this tuning thing. There's two things in the tuning thing. There's this bumpy, clunkiness. There's three things. There's three things here. One is this tuning. The other one is this, the loosey goosey thing. I've got to change the grommets, and that can be challenging because the screws and whatnot that are down under the chassis here could be in amongst all the wires, and it could be a challenging thing. Okay, I can do it though. And the last thing is solve the scratchiness in the tuning. It sounds like the plates that are supposed to mesh nicely are touching down in this area. Three things. Very good. So thanks a lot for watching today. I'm on my way out to have a nice day outside. And we'll see if we can really get this guy going tomorrow. Great. See ya.